Hi, welcome you all for the next series. In this series, we are going to see about a list of serial communication protocols, and that first we are going to see about Uart. So before getting into the Uart communication protocol, we can just go through what is serial communication in embedded system and what are all the communication protocols which comes under serial communication. Here I have mentioned embedded system communicates with the external devices using serial communication protocol. What is meant by communication and what is protocol? First we can understand that. So communication is nothing but we are going to exchange some data between two devices. Like I want to talk with person 1 want to talk with the person 2 means he is going to exchange or exchange the data between person 1 and person 2. So data exchange is called communication, and protocol in the sense they are following some set of rules to exchange some information. For an example, he is a Tamil guy and he is a Hindi guy, so they both doesn't know, he doesn't know Hindi and he doesn't know Tamil. So in common they are using a language English. Via the English they are communicating with each other. So this is the rules between person 1 and person 2. Similarly, I want to communicate between my device 1 to device 2. Okay, I want to communicate between device 1 to device 2. We are going to exchange some data between device 1 and device 2. It must have some set of rules or set of information. According to that only they will make a data exchange between them. Okay, this is communication protocol. Protocol is nothing but it is a set of rules which will be used to exchange some information. And generally we are having three types of modes, isn't it? One is simplex mode, and another one is off duplex, and last one is full duplex. I'm not going to explain what is simplex, what is off duplex, what is full duplex, because you all know that, but I just want to reference these things because when we are getting into the communication protocol we will categorize whether it is comes under simplex, off duplex or full duplex. Okay, that's all about the introduction. Serial communication in the sense I'm going to communicate between device 1 to device 2 serially instead of going for parallel. For example, 4-bit I want to transmit means I will transmit first bit, second bit, third bit and fourth bit via a single line. Okay, this is serial communication. What about parallel communication? I want to transmit 4-bit. Instead of going with one line, I am going to have 4 lines. Like this will carry data 1 and this will carry data 2. This will carry data 3 and this line will carry data 4. So simultaneously I can transmit all the data using parallel communication. In serial communication it will be transmitted bit by bit. Okay, currently we are going to see about serial communication because if you are going for parallel communication the wiring will be high and cost will also be high. So hence we are going for serial communication. So under serial communication 4 main communication protocols are available. First is Uart, universal asynchronous receiver and transmitter. Next one is SPI, then I2C and CAN. In this video we are going to see about Uart communication protocol. Okay, generally these communication protocols used for communication between the sensors to the microcontroller or microprocessor. If I want to do any configuration that can be done using the serial communication and automotive networks and debugging, in all the cases these serial communication protocols are used. Okay, now let us get into the first serial communication protocol, Uart. Uart is nothing but universal asynchronous receiver and transmitter. In general we are mentioning it as two-wire system because it will have TX wire and RX wire. TX is the one which is used to transmit the data. RX is the one which is used to receive the data. Okay. It is a device to device communication protocol, and here we can again go with device 1 and device 2. Okay, device 2. So I have a separate line for TX and another separate line for RX. So it comes in a which communication mode? It has a separate line for transmission and separate line for reception, means it supports for full duplex communication, which means that simultaneously I can transmit as well as I can receive the data in Uart. Okay, characteristics are asynchronous communication. Asynchronous and synchronous in the sense, asynchronous means there is no synchronization between device 1 and device 2. If it is go with the synchronized mode, then it comes under Uart. Okay, but this Uart is an asynchronous. Asynchronous in the sense the transmission between the two devices does not follow any clock signals. I mean, it won't depend on any clock signal. It is irrespective of the clock signal. It does a transmission and reception. Okay. So no clock signals are required. It uses two wires, and real-time examples are PC serial terminal communication. I want to debug and I want to connect my microcontroller to my PC using this serial terminal. As well as in GPS module for LMA messages, we are going with Uart. Bluetooth module is also using Uart. And here they have given a simple connection. If suppose I want to connect my microcontroller with a device via Uart, means my microcontroller transmitter has to be connected with the device receiver, because my MCU is sending the data. So this is the transmitter, but the device is receiving the data, isn't it? So we have to interchange and connect it. MCU TX has to be connected with the device RX, and MCU RX will be connected with device TX. Okay, now baud rate. I said device 1 and device 2 are simply connected with two wires. One is the TX wire. So one is the TX wire transmitter, and another one is the RX wire. So two wires only available in Uart between the two devices. So if you see here, I am sending some information. How do my device 2 will come to know that data is coming, as well as how it knows, how it is supposed to know that how to read the data which is sent by device 1. So these informations will be given to both my device 1 and device 2. For an example, my device 1 is sending an information with a particular speed or particular baud rate. Okay, then the same baud rate has to be set in D1. For an example, it is running in the speed of 10, and my device 2 also should run in the speed of 10. Then only it can able to read the data clearly. Okay, so baud rate is the speed of data transmission. Okay, it represents bit transmitted per second. If suppose I am setting the baud rate as 9600 in my device 1, then obviously I have to set the device rate as 9600. Okay, instead of that I am going to set the baud rate as 115200, means similarly I have to do the baud rate setting both in my device 1 and device 2. Then only it can able to read the data sent by my device 1. Okay, so that's mentioned here. Both devices must use the same baud rate. Multiple baud rates are available in Uart. In frequent, they will use 9600 or 115200. Okay, so this is the frame format. Now you know device 1 and device 2 both are transmitting and receiving in the same speed. That's okay. Now both my device 1 and device 2 are working in the same baud rate. But if suppose I am sending a data, okay, I am sending a data, how my device 2 knows when to read the data? I mean, how it knows the data is receiving. Something has to be informed from my device 1 to device 2. Then only it can able to understand data is receiving right now. So we have to read the data. Okay. So device 1 is sending, device 2 is not aware about the data receiving means it will lose the data and it doesn't know where it has to start the reading and when it start to finish the reading. Okay, for that purpose they are going for data frame. Data frame is nothing but usually data will be, some information will be sent from device 1 to device 2 means it will be transmitted as a packet. So inside the packet it have some list of bits, like first one is the start bit, and then I will send the data which has to be sent from my device 1 to device 2. It may be ranges from 5 to 9 data bits. I'm sending a data 5 bits or 6 bits data I'm sending, or 8 bit data I'm sending, that can be sent using this data frame. After that I'm using a parity bit. If it is a even parity or odd parity, that I have to mention, because if suppose one of my bit is corrupted means that will be known by using this parity bit. At the end I'm having a stop bit. Okay, now start bit is okay, stop bit is okay, and data frame is okay. How my device 2 knows when the start is happening? So for that, if you take a TX, this is my TX line. So ideally this TX line will remain in 1. Okay, ideally it will be high. If suppose my device 1 is going to start means at the time it is pulled down to 0. So if logic 0 occurs means then my device 2 knows data is coming. This is our start bit. So next will be our data frame. So it got an idea. Now the packet is arriving. This is the start bit. Then I will send either 5 bit to 9 bit. It's depending upon our configuration. Okay, after I have sent, I have to give the parity. It is even parity or odd parity, because if suppose any one of the bit is corrupted bits, that can be identified using the parity bit. And at the end again I have to tell my device to the packet is ended. For that we are going for stop bit. Stop bit is nothing but it will move from 0 to 1. Okay, this is the stop bit. Once it reaches the logic 1, then it understands that the packet is arrived completely. Okay, so by using start and stop bit, device 2 will start to read the data and get the information from the packet. Okay, so start bit indicates the beginning of data, which is the actual data which is used for checking the error, and the stop bit is the end of frame. Next one is Uart polling versus interrupt. Uart polling is nothing but my port will be continuously checking any data is arriving or not. It will cause CPU wastage. Okay, if you go for interrupt method, my CPU will do its own work. Whenever my Uart data is received, at the time it will create an interrupt. Then only my CPU give attention to that Uart receiver data. Okay, polling is nothing but it continuously checking the Uart status instead of doing any other work. In interrupt method, CPU will do its own work. Whenever data is received, at the time it will create an interrupt. At the time only CPU will give attention to this Uart data. Okay, thank you. We can meet up with the next communication protocol in the next video.